Hi everyone, glad you could join. My name is Salim, I'm a DevOps engineer, and in this video, we've got a cool task ahead. We're setting up a dev environment in AWS, and we're going to do it with Terraform. AWS is where we'll be living. It's got all the building blocks we need for our use case. And Terraform is the tool that will help us arrange our environment resources without having to go into the AWS console and start clicking around. Just a heads up though, I'll assume you've got the basics of AWS down, like what an EC2 is, what a VPC looks like, and that you've got a handle on computer networking basics, like subnets, IP addresses, side annotation, routing tables, routes. The same with Terraform. I'd assume you know the basics, like writing a config file, spinning up a resource, that kind of thing. Alright, so let's roll up our sleeves and get into it. Our architecture is built on several key AWS services, orchestrated by Terraform's infrastructure as code capabilities. We start with a VPC, an isolated network space within AWS that contains all our project's resources. Within this VPC, we have allocated a public subnet, which is where our services can be reached from the internet. Our security group acts as a virtual firewall, controlling the inbound and outbound traffic for our EC2 instance. The route table is responsible for determining where network traffic from our VPC is directed. The Internet Gateway connects our VPC to the Internet. It lets our EC2 instance send and receive data according to the security group rules. For secure access to our EC2 instance, an SSH key pair is generated and managed, ensuring encrypted and authenticated sessions. The private key will be kept with us, and the public key will be installed on the EC2 instance. Terraform's configuration is split across several files for modularity and maintainability. Providers.tf sets up the providers we need for our use case. Main.tf outlines the resource definitions. Datasources.tf, which will be used as a way to fetch data from external sources for use within our Terraform configuration. Variables.tf holds our customizable parameters, and locals.tf provides a way to use frequently repeated values efficiently. We use templates like generate SSH key template to create the SSH key pair, Linux SSH config template to set up Linux-based SSH configuration, and user data template to initialize the EC2 instance. With Terraform, we gain the ability to create, modify, and maintain our infrastructure with precise, codified blueprints, enabling consistent deployment and scalability. To automate the setup of our AWS resources directly from our development environment in VS Code, we need an IAM user with programmatic access. This type of user does not use the AWS console, the web interface, for manual operations. Instead, it's equipped with an access key ID and a secret access key, which are used to authenticate API calls made by our Terraform scripts running from VS Code. So let's go ahead and create one. First, we start by logging into the AWS Management Console. Once in, we navigate to the IAM service. Next, we go to User Groups to create a user group. Let's name it DevOps User Group. We'll attach to it the policy Administrator Access, granting administrator access to its members. Now we move to the Users section to create a new user. We'll name it DevOps User. We assign DevOps user to the DevOps user group. This way, the user inherits the group's permissions. We click Next, and then Create User. Once the user is created, we select it to generate access keys for programmatic access. We select this use case, confirm, and then click Next. And now we create the access key. Now make sure to download and securely save them. Now that we've set up an AWS user specifically for programmatic access, our next step is to integrate these credentials into our local machine. This allows us to seamlessly interact with AWS services directly from VS Code. First, let's install the AWS Toolkit in VS Code. Head over to the Extensions panel, and in the search bar, type AWS. Find the AWS Toolkit in the results and click Install. Once installed, go to View, Command Palette, and then type in AWS Create Credentials Profile. Now we're ready to enter our credentials profile. Let's use the access key we've downloaded earlier. First, we use the access key ID, then the secret access key, and then this file pops up. It's also stored under this path. Now, make sure you change the name of the profile to our IAM user, then save the file. To connect to AWS using this newly created profile, head over to the Explorer panel, click on these three dots, then select Switch Account. Here you should see our profile. Click twice on it to activate the connection. Now you should see a successful connection established, displaying available AWS regions. Since we're working on one specific region, then let's hide the one we don't use. Right-click and choose Show or Hide Regions. Scroll down and deselect the region we don't need. Now our workspace is organized and focused. As a final step in setting up our environment, we're going to install the HashiCorp Terraform plugin. This plugin is a game changer for anyone writing Terraform code. It offers features like auto-completion and syntax highlighting. So let's get it set up now. First off, click on the extensions icon. Then in the search bar, just type Terraform. We're going for the official HashiCorp plugin here. Let's hit install, and that's it. Now our VS Code setup is neat.